Ever stop to wonder about the genes that can cause cancer and how we can prevent these genes from turning into real cancers? Well, that's exactly what we're going to explore today. You see, our bodies are made up of millions of cells, and within each cell are genes. Now, these genes are essentially the blueprint of our bodies, instructing cells on how to grow and function. However, sometimes changes or mutations occur in these genes, which can cause cells to grow out of control, potentially leading to cancer. This is where cancer genes come into play. These are genes that, when altered, have the potential to cause normal cells to become cancerous. Understanding these genes and their functions can provide invaluable insights into cancer prevention and treatment. In today's video, we're going to delve into some well-known cancer-related genes and discuss strategies to prevent or slow down their potential to cause cancer. Before we delve into a comprehensive list of cancer genes, let's focus on a specific gene that plays a significant role in many types of cancer: the BRAF gene. The BRAF gene provides instructions for making a protein that helps transmit signals inside cells, which are important for cell growth and division. However, when this gene has certain mutations, it can lead to the cells growing and dividing too rapidly or in an uncontrolled way, potentially leading to cancer. Mutations in the BRAF gene are most commonly associated with melanoma, the most dangerous type of skin cancer, but they can also be found in colorectal cancer and certain other cancers. In melanoma, these mutations are often caused by excessive exposure to ultraviolet UV light, which is a strong reminder of the importance of sun protection measures. These measures include wearing sunscreen, putting on protective clothing, and avoiding excessive UV exposure, especially during peak sunlight hours. When it comes to treatment, targeted therapies and immunotherapies have been developed specifically for cancers with BRAF mutations. These therapies often work by blocking the action of the mutated BRAF gene, thereby slowing down or stopping the growth of the cancer cells. They're often used in combination with other treatments for a more comprehensive approach. Understanding the role of the BRAF gene in cancer development not only helps in the early detection of certain cancers, but also guides the development of targeted treatments. As we move forward, it's important to remember that knowledge is power, and understanding these cancer genes can be our first line of defense against this disease. Let's start by taking a look at some well-known cancer genes and the cancers they're associated with. Breast cancer, for instance, can be linked to the BRCA1, BRCA1, BRCA2, CHEK2, PALB2, PTEN, and NF1 genes. Ovarian cancer often associates with BRCA1, BRCA2, BRIP1, RAD51C, and RAD51D genes. Colorectal cancer is usually tied to APC, MLH1, MSH2, MSH6, PMS2, and MUTYH genes, while melanoma relates to BAP1, CDKN2A, and CDK4 genes. Pancreatic cancer often involves BRCA1, BRCA2, PALB2, and STK11 genes, and prostate cancer connects with BRCA1, BRCA2, CHOX-B13, and ATM genes. Lastly, endometrial cancer usually involves MLH1, MSH2, MSH6, and PMS21 genes. Now, let's delve a bit deeper. The BRCA1 and BRCA2 genes, for example, are associated with hereditary breast and ovarian cancers. Mutations in the TP53 gene, also known as the P53 gene, can be linked to various cancers, including breast, colorectal, lung, and ovarian cancers. APC gene mutations are associated with familial adenomatous polyposis and colorectal cancer. The EGFR gene, standing for epidermal growth factor receptor, can be found in some lung cancers and other types of cancer. The KRAS gene mutations are common in several cancers, including pancreatic, colorectal, and lung cancers. And finally, the HER2 gene, or human epidermal growth factor receptor 2, can be found in some breast, ovarian, and gastric cancers. Now that we know some of the main genes associated with cancer, let's discuss how we can prevent or slow down their potential to cause cancer. Preventing or slowing down the potential of these genes to cause cancer is crucial. Here are some strategies. For genes like BRCA1 and BRCA2 associated with hereditary breast and ovarian cancers, genetic testing for high-risk individuals and prophylactic surgeries for those with identified mutations are key strategies. Regular screenings such as mammograms and breast MRIs also play a vital role in early detection. The TP53 or P53 gene linked to various cancers can be managed by avoiding exposure to carcinogens like tobacco smoke, and UV radiation. Regular cancer screenings and lifestyle modifications, such as a healthy diet and regular exercise, are also recommended. For the APC gene associated with familial adenomatous polyposis and colorectal cancer, early-age screening, colonoscopies, and lifestyle modifications can reduce the risk. These include maintaining a healthy weight, eating a high-fiber diet, limiting red and processed meats, and avoiding tobacco and excessive alcohol. The EGFR gene, found in some lung cancers, can be managed by avoiding tobacco smoke and environmental pollutants. Targeted therapies like EGFR inhibitors also prove effective for patients with EGFR-mutated lung cancer. The KRAS gene, common in several cancers, can be managed with lifestyle modifications like maintaining a healthy weight, regular exercise, and avoiding tobacco and excessive alcohol. Targeted therapies and immunotherapies under clinical supervision are also beneficial for specific KRAS-mutated cancers. Lastly, the HER2 gene found in some breast, ovarian, and gastric cancers can be managed with HER2-targeted therapies and regular screenings for early detection. Genetic counseling and testing are also recommended for individuals with a family history of HER2-related cancers. These strategies can go a long way in preventing or slowing down the development of cancer. As we move forward, let's delve deeper into the prevention strategies mentioned earlier. Regular screening is essential as it allows for early detection and treatment of cancer. This includes mammograms for breast cancer, colonoscopies for colorectal cancer, and Pap tests for cervical cancer, among others. A healthy lifestyle can significantly reduce your risk of developing cancer. This includes maintaining a healthy weight, eating a balanced diet rich in fruits and vegetables, and exercising regularly. Limiting the consumption of processed and red meats, avoiding tobacco use, and moderating alcohol intake are also essential. Sun protection can help prevent skin cancers linked to the BRAF gene. This includes using sunscreen, wearing protective clothing, and avoiding excessive exposure to the sun, especially during peak hours. Vaccinations can also play a crucial role in cancer prevention. For example, the human papillomavirus (HPV) vaccine can help prevent cervical, anal, and other types of cancers, while the hepatitis B vaccine can reduce the risk of liver cancer. Chemoprevention, the use of drugs or other agents to inhibit or prevent the development of cancer, is another strategy. For instance, tamoxifen and raloxifene are FDA-approved drugs that can reduce the risk of breast cancer in high-risk women. Lastly, genetic counseling is recommended for individuals with a family history of cancer. This process can help you understand your risk of developing cancer, the role of genetics in cancer development, and the options available for managing that risk. By incorporating these strategies into your life, you can take a proactive approach to prevent or slow down the progression of cancer-associated genes. Summary and conclusion. Let's do a quick summation. We've journeyed through a list of renowned cancer-linked genes, such as BRCA1, BRCA2, TP53, APC, EGFR, KRAS, and HER2. We've also had a discourse on various preventative maneuvers. Always bear in mind, knowledge is a compelling force. By understanding these genes and the ways to obstruct them from inducing cancer, we have the power to take a proactive stance towards our health. A voiceover. That's it for today's video on decoding cancer genes. If you want to continue learning about medical and health topics with us, make sure to hit the subscribe button for the MedSign Health 360 channel. We aim to provide you with high-quality, informative content that aids in your understanding of complex health matters. Don't forget to give this video a thumbs up if you found it helpful. Your support means a lot to us and helps us to continue creating content like this. We'd love to hear from you. Do you have any questions or thoughts about what we've discussed today? Feel free to drop them in the comments section below. And if you know someone who could benefit from this information, don't hesitate to share this video with them. Thank you for watching, and remember, your health is in your hands. Stay informed, stay proactive, and stay healthy. See you in the next video.